So yeah, hello everyone. So yeah, I'm working at Parity with Rob to make a mic, and I'm working on the UI part. So basically, if you want to try Parity, you will download the software, and when you launch it, you can access a web application through your Chrome, Firefox, or whatever browser. That will help you play with the Ethereum network and do all kinds of things. So this is just a small presentation of what you would be able to do with it. So yeah, this is just a boring list, but yeah, it's mainly the screenshots. So you have several parts. So the main one, the first one that was built, is the account management. So this is like the wallet part. So you can create easily new accounts. You can import accounts from previous versions or from backups, from whatever. And through this page, you will access all your accounts, which can also be hardware wallets right now. If you heard about the Ledger Nano, for example. It could be also something called multi-sig wallets. So for example, you could create a wallet which will be shared, the ownership of the wallet will be shared amongst several people. So it could be, for example, you say everybody in my family is the owner of the wallet, and anybody from these accounts can spend the money that is in this wallet. And so this is built in Parity. You have, so this is the account creation. So this is the account page where you can see every transactions that has been made, whether you made or a transaction you received to your account. You can transfer money, you can buy some Ether from Bitcoins or any other currency through Shapeshift. And we have built-in token supports. So in the Ethereum world, it's really easy, and we'll talk a bit more about this later, to build a token. So you could have, for example, this is a beer token. So you can just create a token for whatever you want and give it the value you want it to have. And register the token in our UI, and then transfer this token to anyone you'd like to transfer this token, and it will show up here. There are also other features like email verification, SMS verification, so you can link your Ethereum account very easily through just a few button clicks to one email or one telephone number, and so the raw value of the email or phone won't be stored in the blockchain, but only the hash. So you can given an email address, you can verify that it belongs to this Ethereum address. You cannot go the other way around. So this is the multi-sig wallet I was talking about. So for example, here it's a wallet with a lot of Ether, which has 3 owners, and to do any kind of things. So if you want to transfer, let's say, 10 Ether from this wallet, it has to. So it's described in the contract that 2 owners of this wallet have to agree on the transaction. So if you are only one of the 3 owners, you can ask for another one to validate the transaction, and if he does, then it will go through. If not, it won't. And there is also built-in contract developments. So in Ethereum, you have this thing called smart contracts. And you can write a smart contract in several languages. The main one being Solidity, which looks a bit like JavaScript. And so to write smart contracts, you have to. So yeah, as I said, you have several like higher level languages. that gets compiled to something called EVM code, which is then understood by the node, the clients like Parity and Get and other ones. And so the idea here is that within the UI you can write a smart contract and compile it from the browser and deploy it to the network and interact with it. And yeah. And so I'll show you this in a bit more interactive way, I guess. So yeah, so this is what the UI looks like in Chrome, in a browser. So yeah, you have several accounts. So these are my accounts, and these are the wallets I created. So with the different owners of the wallet. So for example, here the 3 owners are accounts I own. It's not really useful. And so yeah, for example, this is an account page. So you can see every transaction I've made. You can transfer some money to any other account. For example. And so in Parity, whenever you want to send a transaction, whether it's a value transfer or a contract deployment, or if you want to just interact with the contract, you will have this little signer pop-up that will pop up asking you for a password. So the account is stored on your local machine, but encrypted with a password that you have to type when you want to make and execute a transaction. So then you have to wait for the transaction to be processed by the network. So here I'm using, it might be not connected.
No beauties.
You're still syncing. No, but you don't have any peers.
No, that cannot be connected. Let me just restart it. Sorry about that. Okay, so yeah, also something that could be useful. So you can, when you start Parity, you can select several networks. So there is the main network, some test networks, and you have a development network that is useful if you do development. And the idea is that a new block is mined whenever you send a transaction, so you don't have to wait for the network to process the transactions and all. It's just instant. So if we make the same thing again. So then the new block is has been mined, and the transaction has gone through. Yeah. So one other thing is we have built-in applications called we call them dApps because it's decentralized applications, and so we have some built-in applications that anyone can use, like I don't know, like just a JavaScript console which gives you access to useful commands for testing and deploying stuff. A registry, and the idea is that anyone can register its own application. So if you want to write a decentralized application, you can just go to the dApp registration application and say, okay, I have written this application. It's accessible from this URL, and everybody will have access to it and will be able to use your application from this application tab. If you deploy it to the main network or test network, and yeah, so this is the contract page. So whenever you write a contract, then you will be able from the UI to interact with it. So when you write a contract, you write mainly like methods, so functions. That user can call to interact with it. Maybe I will give you just a small example, which is the one of the most famous one is the token contract. So which is just so it describes how a token should be able to do. Like the very basic interface of a token. So you have several function definitions. First of all, you have an integer saying how much token do we have accessible in the network, and then functions. So you want to be able to see the balance of a certain address. So you give an address as an input, and it will return you the balance of this address. Obviously, you want to be able to transfer some token from one person to another, which is the transfer function. So you give an address, a value, and it tells you if you can actually transfer or not. And then you have so these three other functions are just to say that you can allow someone else to use your tokens. You can say, okay, for example, Rob, you can use 10 of my tokens, and then he will be able to transfer maximum 10 of my tokens to anyone who wants. So yeah, these are the functions that specify how you would interact with this contract. And then you have so you have to implement them actually. So this might be a bit technical for us, but this is the basic transfer function. So the idea is that first of all you want to check if you have enough money. So if you only have 10 tokens and you want to transfer 100, you shouldn't be able to, right? So this is just the first line. You want to check that the sender has more, the balance of the sender is greater than the value you want to send. And if it is, then you just subtract the value from the balance of the sender. You add this value to the balance of the receiver, so the address you gave at the beginning. And then you can, so this is an event. It was on the page before. You can also add some events which won't modify the store and the data of the contract, but it's more for to be able to give information of what happened in the contract. So for example, there is a transfer event which is triggered whenever you make a transfer, just to say this person sent this much ether to this token to this address. And so, for example, so if you want to develop a new contract, you can write your contract code here. You can load. There are some contract snippets available to anyone. So, for example, this is an implementation of the token contract. So it has to compile. Then you can deploy it to the network. So this is just a token. So when you create a contract, you can give some initial values to the contract. So here this contract asks, it's not very bright, the initial amount of tokens you wanna have. So for example, let's say you have 100 tokens. You can give a name to the token. So like this token. Yeah, decimal units. So, for example, if I have 100, you might want to display that it's only 10. Yeah, so the one decimal. And you can give a symbol. This is just for display purposes. So, I don't know. Sorry. I selected the wrong account. So, as Rob explained, to interact with the blockchain, you have something called a gas, which is basically the computation needed to execute something. So, for example, deploying a contract. And so, to interact with the blockchain, you have to have some Ether. So, I selected the wrong account previously. Okay, so now the contract has been deployed, and it is now here. Yeah. And now you can see that, so this is the contract we just deployed, with the right name, the symbol, the total supply. And so initially the total supply is given to the one who created the contract. So if we execute this balance of function and we give the address of the one who created the contract, which is this one, to display 100. And now if I want to transfer so execute a function on this contract, for example, the transfer, then I can say I want to send like 10 to the guy. So, like, transaction has gone through, and now I only have 90. And what is this one? Yeah, got 10. And then you have the events, which just shows what happened in the contract. So yeah, I guess that's it for the UI, and yeah. If you have any questions or remarks? Yeah.
Are there any other Ethereum wallets online, and why is yours better?
Well, there are other wallets. You have online wallets. One called I think my Ether wallet is online, so you can access through your browser. When you can download is Mist. Yeah, so you have other wallets online. Why is our better? I guess you have a bit more. So usually the wallets, so these two are actually, it's mostly this page. So you have accounts, you can also create wallets, you can transfer value, you have to get integration on them, but it's mainly this, and you don't really have this whole contract, it means to have some contract. You can interact with the contract, but you cannot write one and deploy it on the network. You don't have this built-in signer thing where it pops up this thing to put your password in. So yeah, I just have this functionalities, and it's yeah. Do you want to add something?
So you mentioned My Ether Wallet. So it's got a really nice interface. It's all like client-side JavaScript, but it just connects to the nodes that they run. So they found that in certain situations, when there was a lot of demand on the network and on My Ether Wallet in particular, that their nodes were getting overloaded. Whereas with Parity or with Mist, you're running your own node, and you know that you're not going to overload your own node. In terms of why Parity is better than Get, this is a little bit of a heated subject, so I won't get into that too much. I think it's better. I'm a bit biased.
Yeah, we can talk about it more during the networking part, I guess. Okay.
Alright, thanks.